Welcome to the third episode of AI and Data Governance with Dr. Vega. Today, I am incredibly honored to sit here and discuss such a sensitive and important topic in the industry, in the national landscape of research and also application. I am here today with Dr. Moe Khaleel from Oak Ridge National Lab. He is one of the associate lab directors. And this is not just a normal kind of opportunity. This is a very special opportunity because, as I like to think, when people is faithful in the few things, they are entrusted bigger things. And Dr. Khaleel here has been entrusted with great things on the topic of energy, security, and the safety of our country. And so with that, welcome to the podcast, Dr. Khaleel.
Thank you, Ronaldo. Thank you.
Absolutely. So let's get the conversation started here. And for our audience to have a feel for what we will cover, we will start with some background on your development. And we will then move on to some of the key influences in your life.
Sure.
And we'll be looking for some of the stories about your journey. I then want to jump into the topic of emotional intelligence. There is a particular quote in the recommendations in your LinkedIn profile that really caught my attention that we're going to come back to.
Sure.
And then I want to kind of dive into decision making in leadership and the future of ORNL on the topic of AI. Something that many people is not talking about are their first principles on the topic of AI and data governance, such as first principles in physics. Do we have first principles for data governance? And then we're going to dive into the impact of AI on society, culture in companies, and metrics that we could use. Sure. So that is the topic for today.
Sure.
With that being said, I'm going to take some liberty on giving you my impression of your professional experience, but please feel free to grade me. If I fail in some aspect in the summary I provide, just correct me.
Don't worry about it.
So you started your studies in engineering. You had a particular interest in material sciences. You took this background and you found that you needed to expand your knowledge in business. After your bachelor's degree, you went to get your MBA from University of Washington, and then you went back to school again to do a master's and a PhD in structural engineering and structural mechanics from Washington State University. Why the intensity on materials and structures with a touch of business is the first question.
So first of all, I believe, when you build a strategy, a technical or a business strategy, it needs to be grounded to economics and so on. So I really have an interest in the intersection of strategy, strategic directions, and economics. And I think that's really important, because a lot of times, macroeconomics affects your strategy as a company and as an entity, as anything we do, right? And, but you can scale it down to my level. It doesn't have to be macroeconomics. It can be other things. I actually, when I went to the University of Washington, I learned a lot, in the MBA program. Actually, I did it after my PhD, not before my PhD. And so the interest there, there's in a general MBA program at the Foster School of Business at the University of Washington, you learn a lot about HR type related things. You learn a lot about accounting and how you schedule projects and so on. But the thing that really intrigued me quite a bit is really that intersection of strategy and macroeconomics. And I have a knack for strategy, so I felt home. I learned a lot. One of the most interesting things in the class, I was maybe the oldest person in the class, and there's a lot of younger people. And normally, at the University of Washington, you do case-based studies, right? And I learned a lot from my colleagues, my younger colleagues, thoughts and ideas and things like this. It was a great place for me to learn at my age at the time. Okay, it was great.
You continue. You finish your degrees. You spend about 5 years early on as a teaching assistant and an assistant professor, teaching on the same subjects. Before you went to a national lab for 20 years, PNNL, the Pacific Northwestern Lab, you were 5 years in the teaching component. What happened during those teaching years that prompted you to then leave the teaching component to then dive into the national lab space?
So first of all, teaching. I think teaching was very rewarding things for me. I taught a lot of classes in mechanical and materials engineering and also in civil engineering. A lot of them deals with modeling and simulation, computer methods, in structural engineering, advanced mechanical vibration, theory of plasticity, and all of that. The great thing about teaching is actually you feel, you're delivering your messages and also you're harvesting the awards very quickly. So when you teach, the students learn and you feel, you know that they learned and so on. They start asking you all kind of questions. It's really a great feeling. I left Washington State, for a couple of reasons. I think one is career growth, but I think the more important one is I made a promise to my wife, if she finds a job, we got a new baby at the time, 1991, December 1991. If she finds a job somewhere, I will go. And she did. She found a job where her parents are. And that's actually in Richland, Washington. And that's one of the reasons I moved to Pacific Northwest National Lab. It was a great lab. It was a great journey for me there.
Diving into your 20 years, it's such a remarkable journey. You started what I would call, and this is why the comments I shared at the beginning, if you find someone to be faithful in the little or the few things, they can be trusted with more. And I can see that when you started in PNNL, you started at the very beginning of the development. You started as a research engineer, and then you quickly moved to lead the design and manufacturing technical network, and then became the manager of the advanced manufacturing product line. You get promoted to lead the computational mechanics and materials group, which is further cementing the use of material science, now expanding onto high performance computing. You led the energy programs shortly thereafter, and this led you to become the director for computational sciences and mathematics. So in my way, I'm kind of internalizing. You started in materials, you go into computing, you're diversifying into energy, and now, when you were here at PNNL, computational sciences and advanced computing. Am I so far all right in your journey?
Yes, you're right.
Okay. Now, in this last stage, you oversaw 150 people, working on the high-performance computing, data management, computational modeling, and you led a budget of over $400 million in the annual budget. And you directed, these major energy and environmental programs. And I found that this was kind of a highlight as I studied your background. There was a push or some internal motivation you had in drive inter-division or inter-organizational collaborations. I think that this was kind of like a big change, because everything before was very focused on your own area, but now you're kind of creating a lot more synergies. And then the question here is, what was, in all of those 20 years, with all of those great accomplishments, teams that you led, funding that you brought, what was the most technically challenging transition or experience until this point of your journey, and why?
Well, first of all, let me start with maybe a correction, okay?
Please.
On the $400 million, that was not at Pacific Northwest, that was here at Oak Ridge. But the U.S. national labs are really great places to start a career at. The reason is you got great mentors, right? We actually, when I started at PNNL in Pacific Northwest National Lab in 1993, I had a lot of mentors. My group leader, Fred Simonon, Dr. Fred Simonon, was a graduate from Stanford University in fracture mechanics. He actually taught me fracture mechanics. And the reason is we wanted to do, at the time, the big question was, how do we extend the life of nuclear reactors from 40 years to 60 years. And what we tried to do is to introduce in-service inspection. But you have to focus on certain systems. We focus on piping and vessels. And we created computational codes that with non-destructive evaluation coupled with them computationally and their probabilistic fracture mechanics code. So I actually taught Fred the probabilistic methods. He taught me fracture mechanics. So there's a lot of people when I was there, they really helped me quite a bit, right? I think the big transition when you come into a national lab and the big challenge is you come in as an individual contributor. The national labs are set to really do big science, solving big problems, team science, right? And then how do you fit in a team? What's your role in a team and how you do that? That's a challenge, right? But, again, when you have a lot of great people around you, it's easy. So let me give you an example. When I got to PNNL, it was also at the time of President Bill Clinton. One of the big things was created at that time, something called PNGV, the Partnership for New Generation Vehicles. How do we actually lighten the weight of vehicles? So one of the ways you take steel out of the cars and you replace it with something lighter, and in this case, aluminum, right?
Okay.
But there is, if you take, we worked on the Cadillac Eldorado. At the time, the Cadillac Eldorado door, you need 14 pieces to be put together. Every piece, when you do it in steel, you have to have a male and female die. Every die costs about $1 million. They have to fasten things together, weld them together, right? So part count is a lot, so that actually increases the cost and so on. But you want a material that gives you the same performance. So we worked on something called superplastic forming of aluminum alloys. We took actually a material that used to take over 30 minutes to form a typical part, and we formed it in 72 seconds. It became commercial. GM took it, commercialized it, they used it, they made doors, they made hoods and trunks out of this material. But how we did it, you have people who do material science, you have chemists, you have mechanical engineers, you have technicians, you have computational people, etc., right? So we all came together, and with the idea is, what can we do to invent a new material that gives us these properties, but also meets commercial requirements of being able to form it fast? Because again, you're heating these materials close to the melting temperature. That means it's a lot of cost. So you cannot wait for a long time to form a part. So that was really an interesting thing. So transitioning from being an individual to working in team science is really a challenge. But it's a great thing, to meet, right? Okay, you learn a lot. You learn a lot from everybody. And you grow as an individual. You grow as a scientist, as an engineer.
How does it look in a national lab? That dynamic that you're describing. I have from my experience, in the industry, we sometimes have moments of crisis, and we do this thing called war rooms.
Sure.
When things are going not in the best direction, and you have the brightest people locked in a room, almost literally, and the brightest minds, regardless of titles go away, and real collaboration happens. Where data was hard to be found, you find it quickly.
Right.
Where the techniques were not known, somehow people in the collaboration find the right publications and I have the concept from industry, and the tempo that there is an element of time that forces people to forge those ideas into new solutions. But how do you do that in a national lab? How do you introduce that? Because sometimes it doesn't feel like the customer is suffering. You're innovating something that doesn't exist. It's not like a war room in an industry.
Right. So really, in all honesty, Ronaldo, it depends on the topic and on, I'm saying maybe the day. So in general, if you're doing research, like basic fundamental research, the whole idea with basic and fundamental research, you're going to add to the state of the art in terms of scientific discoveries and so on. You're going to add to the state of the art. So you need to bring original, thoughts. And a lot of times these original thoughts, original ideas, original contributions, they come by serendipity, they come by a lot of the work with other people and so on, but it takes time. right? But there is times here at the national labs we have unique capabilities to apply them on applied problems or translational problems. So I'm going to give two sets of problems, okay? One of them is related to geospatial intelligence, mainly taking satellite imagery and trying to digitize them using artificial intelligence and machine learning, right? If you try to, say, take a city and trying to digitize the buildings in a city, it's going to take a long time to do it manually. So how can we do it, quickly, right? So the question that came to us is from one of the agencies to look at Mariupol in the Ukraine and to look at the city and to look at the buildings, different parts of the buildings where they needed us to digitize the whole town, see what's destroyed, not destroyed, and so on over a weekend. So our scientists, they come together, on a weekend, they're able to automate the workflow, okay, digitize the entire city, done. Okay, right.
Okay.
Another thing, if you go to a place here within Oak Ridge called Hardin Valley, we have some really, really kind of, I'm going to say, cool things we do, okay, but really, contribute to the economic well-being of this country quite a bit. One of them is called the Manufacturing Demonstration Facility, okay? We are leaders in additive manufacturing, right? But to do additive manufacturing, you want to be able to create parts that you're actually sure about the microstructure, kind of the gene of the material, of what you're printing, not just the shape, but the gene. And you want to make sure it's free of defects, etc. Right? We actually been called on to help with hypersonics, okay? And just for the record, we did not know much about hypersonics. We've been taught about hypersonics by one of our sister national labs, Sandia National Labs. We participated in a span of 1 year in 3 launches of hypersonic rockets. And our materials that we made, very successful, they performed, etc. So you go from knowing nothing to being able to put something, okay. Now, why? Well, because you got a lot of basic science capabilities and you know how to translate science to solutions. And a lot of times that the translation of science to solution is done in the heads of our staff because they work on, science discovery and they work on the translational aspects. But we also have the people, like I said, in Oak Ridge. Oak Ridge is really, really special in terms of its people. People can come together, complement each other, and Oak Ridge has a sense of urgency. Why? Well, just look at the genesis of Oak Ridge. The first continuously run nuclear reactor was done here at Oak Ridge. How long did it take people to do it at that time? 9 months. So can we do anything like that in 9 months? Mm-hmm. Right? Mm-hmm. So Oak Ridge had that genetics, right? But we're able to do certain things. Science will take time, always will take time, right? You have to have the right contributions, and there is peer review, there's a lot of things. But the translating science to solution for missions, we can do it, we do it fast with a sense of urgency.
That's phenomenal. As I continue looking at your journey, you finish your roles at PNNL, and then you left the national. I think you left the national lab.
I did.
Space, and then you went to Qatar to
Yes.
Work in the Qatar Foundation. Tell me, did you leave the country? Did you went to Qatar to
Yes,
do that? Okay,
yes.
tell us about that journey.
So first of all, Brenda, my wife, and I left Seattle on the 12th of May, 2013. We arrived there on the 13th of May. That's our anniversary.
Okay.
Okay, so it was interesting. It's a desert country, Qatar. The Qatar Foundation is the vision of Her Highness, Sheikh Hamouza bint Nasser. She's a wonderful leader, wonderful visionary. Mainly, she's really trying to create, I'm going to say, knowledge-based economy in Qatar.
Okay.
How do you do it? So the Qatar Foundation is really an attempt at that. Second, the Qatar Foundation is an attempt about bringing American-type education to Qatar.
I see.
Right? So you got a lot of American schools, Texas A&M, Northwestern, lots of them, really, Carnegie Mellon, etc. They're there. And so there is actually a campus there for all of these universities, and the Qatari students and expats, they go to these schools. But I actually went there to for the journey, right? Building something from scratch was kind of what I really wanted to focus on: environment and energy. Mainly two challenges: bringing more or less more renewable energy in that region, and second, dealing with the whole water security.
Okay.
Because a lot of the water there is desalinated water. Right, and the degree of salinity in the Persian Gulf is increasing because all of the brines from desalination are thrown back in the sea.
Ouch.
Right? So that affects, the ecosystem and things like this. So the question is, can we actually create better desalination technologies than thermal methods, where you consume a lot less energy, that are a lot more friendly to the environment? Can we bring renewable energy, such as solar cells or concentrated solar there, right? But at the same time, creating that knowledge-based economy, bringing people, creating facilities and infrastructure, right? Because you need people, you need infrastructure, and so on. And how do we actually, teach the culture of science, the culture of research there, and so on? It was a wonderful journey. The vision for the Qatar Foundation, education, for all, it's the vision of Her Highness, and we honestly, went there to kind of figure out a way to make part of this vision a reality, and it was a wonderful journey.
And I think that the mission was accomplished in the short, at least the part of the mission that you were entrusted was, based on my judgment here, establishing this collaboration with Solar Technologies and a $2 billion solar solutions company that was jointly developed with the Qatar Foundation, and a significant facility for all of these labs. It's a phenomenal point in the journey that Qatar is not too far from home for you, Jordan.
Yes.
I now know that you relocated. Did you at any point in your career thought about going back home?
Honestly, it was early after I finished my PhD, but home to me is here in the U.S.
Okay.
Home is where my wife is, my family and friends. Okay. And to me, home is, Tennessee right now, and this lab, right? And I find myself at home here. Here, when if you work in the National Security Directorate at Oak Ridge, and you see the passion of the people in solving and addressing national missions, you feel you belong here. And that's how I feel. I belong here. This is my home. These are my people.
That's outstanding. I think that many people out there in their jobs, wish that they have developed that sense of community, which I think is one of the main reasons people leave their jobs.
Yes.
Is because they don't have a place to belong.
Yeah.
But you belong here.
I do.
And
I
you
really
have
do.
the people that
I find
you love
myself
working
here.
with. That's
Yes.
amazing. Now, your journey after the Qatar Foundation is when you officially started in ORNL.
Yes.
You have talked about the geospatial sciences component, and you have addressed some of the things that you guys are doing now today. These is kind of like the last point in the journey. Can you tell me, you have so many different areas that you're leading right now. How do you foster that collaboration, across the areas that you lead today? Because it's not an easy job,
So normally, when I tell my people here at the lab, we as a directorate focused on mission. Okay, we work with our customers to understand, the challenges they're facing and how we contribute to their successes. And we have to deliver products. But to do that, kind of foundational to that, you have to have great people, which we really do, and you have to have partnerships. And you have to have internal partnerships and external partnerships. Oak Ridge National Lab is a multi-program lab. So that means, whenever you really have a question about something that you don't know, I think you can find the right scientist or engineer at Oak Ridge that actually knows how to answer that question. So we got a lot of great people here. But a lot of times, like the tougher problems are in the industry or with the clients, like in the national security with our, armed services and so on. So you need to partner with them, right, to understand the challenges they're facing. When a company comes to Oak Ridge to talk about a problem, they already solve 80% of it. They really needed 20%. So, but that's a critical 20% enable you to have a working solution. So we partner a lot with companies. We partner with other national labs. It takes a village to, really to tackle some of the big problems. It's not one organization can do it. It's you really need, multiple organizations. And that's, Ronaldo, is really a thing that I really believe we need to do more of. In a lot of ways in the U.S., we tend to work in silos sometimes. Like a university professor works by themselves, maybe a national lab doesn't engage as many people as they should. Companies, try to do something on their own. To really, to me, to outpace the adversaries, we really need to figure out a way where we work together more, okay, change the current system of how we do things, because we have to invent faster than the competition can copy. They will copy, right? But we have to be ahead of them. And it's critical for us to do that. It's critical for us to protect what we create and innovate. But we really need to change. We need to work more together. Universities need to be closer to national labs. National labs need to be closer to universities. We need to be closer to the companies, et cetera, et cetera.
You just, are touching on a topic that I'm also very curious, and that we're going to dig a little deeper, and just to set the stage is this whole thing about intensity versus consistency. We're going to come to this in just a few moments. It's a very interesting topic. We'll come back to that. I want to know about the influences in your life. People that has made a significant mark in your growth, in your development. Why are they the influence that they are?
Well, I think one of them, in all honesty, is my wife. Okay. When you come from Jordan, culturally, you're somewhat different. Okay. So Brenda really helped me in assimilating, okay, with an American culture, right? I still remember, I used to say things, still, I have still an accent. I'm an old man, did not lose it. But, she'll correct me and things like that. So Brenda really been a big part of my life and my development. I have a person who's my friend, but also my boss. He passed away. His name is Anthony Hess. So Tony really, this is, I think, it takes me maybe to 1999. He really influenced me quite a bit, okay? Influenced me about thinking out of the envelope, out of the box, think big, right? And he was a smoker, but this is when I was in Richland, Washington. We'll go outside the building, it's raining or snowing, and I'm with him. I'm not a smoker, but we're talking, okay, right?
Yeah.
And I learned so much from him, about thinking out of the box, okay, being more strategic and so on, but also how, good people come together. So I've always felt Tony is a great supportive of me and others, but I felt that friendship, love, and so on. I actually never felt he's my boss, okay? It just we worked together, we debated things. He had a great questioning mind, and so, I did, but I think he kind of reinforced that in my head. He's a computational chemist, a great computational chemist. So also he helped me with my journey, right? I start actually, I worked on structural materials. After that, I start working on electrocatalytic materials. In a lot of ways, motivated by Tony. I have a lot of people who really influenced my journey. Bosses, and I said my first boss at Pacific Northwest National Lab, Fred Simonon, was my mentor. He used to teach me, right? Other bosses, we had a department head, his name Dr. Don Boyd, and I knew he actually, before he went home, he took care of all of his emails. Right, so I used to go bug him at that time, and he will tell me about the organization, about things I need to do. Just a lovely human being.
Did you have a direct report ever influence you to the way you would change the way that you think?
Yes. So I think that goes to 2004. And, when we, in the labs, everywhere, you do a staff evaluation, you try to evaluate your staff. I was a division director, and one of my group leaders, her name is Leanne Dudney. I used to be mesmerized by the way she writes her staff evaluations.
Mm.
And I learned a lot from Leanne.
Mm.
She's a great manager.
Mm. Outstanding. Let's dive onto the topic of emotional intelligence and leadership. A former colleague of yours has the following to say, has to say the following about you. Talking about you, he is a very patient manager, a serious gifted scientist, highly analytical. He always finds time to thoroughly discuss issues and challenges related to energy, water, and environment. He uses both his heart and his mind. Human relationships, in parentheses, and humanity, close parentheses, mean a great deal to him. And he taught this to many other people, that these connections are an essential part of the scientific process. He's a manager, pioneer, a Renaissance man, a father, and a leader. Can you expand on the topic of what does it mean human connections are an essential part of the scientific process?
Well, so for us, like when you have scientists, we all use our heads, right? That's how we operate. But I truly believe, to be able to do that, we need to have love around us. You need to be comfortable. Sometimes I think, happiness is an important element, okay, of scientific discovery. Because if you have a happy environment, your mind will go where it needs to go. If you're happy and the people around you are happy, serendipity plays a huge role. People talk to each other. The environment around you is important. If you trust people, you dialogue, you actually share, your weaknesses. You talk about things like that, right? Okay, you're willing to talk about things you don't know, right? And things you know, right? And you contribute. I think, discovery doesn't really happen, just one person sitting in a room by themselves. If you have people working together, you have a questioning minds, right, and a trust between them. So to build the trust, you have to have people. You always have to have relations and things like that. So it's really, really important. And in Qatar, it was especially important because I hired people from all over the globe. Different cultures, different standards, different things, right? So for them to have a great relation between them enables them to do bigger things together, right? Togetherness is really critical and important, right? Because again, as I said, science is done in teams, a great science. You can be a wonderful scientist by yourself, but together we can do bigger things, more impactful things. That does not minimize that an individual can create miracles. I'm not saying it does not. Absolutely, there is people who have done that, right? But in general, being together, you can create more, you can do more, right? But to have that scientific debate, scientific dialogue, contributions, questioning attitude, and so on, you need a fabric, a trusting fabric, a happy fabric, people together, right? And then, like if you have people, you can mentor, you can help, right? People will listen, people will receive it, both ways. Mentoring goes both ways, right? I think it's really crucial to have, good relations, good connections to people. And then, like as a humans, if you care about the humanity, you care about important topics, right? Right, like a climate change, right? You care about security, economic security of this country. And we have to care about it because, again, all of us will be affected by it, but the elderly will be affected by it a lot more. The minorities will be affected by it. And so you have to care about other people. You have to figure out a way. What can I do to help in providing opportunities and things like that?
I'm sure that in that journey you encountered a lot of conflict. It does. I mean, I have experienced and I have lived the end result of what you're talking about in building the good environment where the people are on the same page in regards to openness and the collaborations happen. It doesn't mean that they have let's say, the same points of view, because sometimes disagreements are actually meaningful to enrich our knowledge and
Right.
challenge us. And if everybody had, let's say, a standard in terms of how to deal with these conflicts, then we respect each other and everything will be beautiful. But it doesn't always work like that.
Right.
How do you deal with the shades of gray that appear to come on the table when these conflicts are happening? How do you challenge people to overcome that?
Well, I think in all honesty, when there is conflicts, okay, you need to kind of understand, okay, why is this conflict happening? Is it just a person, uncomfortable with the situation? So a lot of times, when you don't have, that emotional intelligence, understanding what's really important, how are they thinking, how are they feeling, right? Then you have actually, if you're a bulldozer, and do yeah, you're going to raise conflicts and things like that. Patience is important, right? When you work with people and so on, but really understanding what's important to people, right? Like, for example, sometimes you get conflict in the scientific community because of credit, right? Who did what, right? But if you really, truthfully, make sure that those who did a certain things are recognized for it, you talk about it early on, you figure out roles and responsibilities of what people are doing, you can resolve conflicts like that, okay? But sometimes there's conflicts about ideas, okay? So in science, there's ways you judge things, right? Based on the fundamental principles and contributions and peer review and what we think, kind of the cumulative state of the art and things like that. But, sometimes some people, if they're stubborn about it, you just have to communicate, talk with them and things like that. I think talking and providing an environment for people to talk is really critical to avoid conflicts, okay? But when they happen, you have to have a system to deal with the conflict, and you have to deal with it in a fair, equitable way, right? You cannot take any conflict, okay, and just tuck it under the rug. You always have to deal with it, right? But you need to have the right instruments and tools to deal with whatever conflict you really have, especially in an institution like Oak Ridge, okay? We actually, like here, we have employee concerns, we have all kind of things in place for people to surface things, right? Whatever they are, and we figure out together, okay, how to solve these, right? To do the right things, right? Okay, but part of doing the right things is encouraging people to raise questions, right? You have to have input. Otherwise, you'll have a lot of problems. Nobody's talking about them.
Yeah.
And so that's a good thing really to do.
In all of that interaction, there is a big component, and the aspect of time, because to be patient, in a way, we have to accommodate for time. Expectations are different.
Right.
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 And it feels to me that if every organization had a clear, I'm going to present some challenges to you to see how you respond.
That's okay.
It would feel to me that if every organization had somewhat of a fast track in the army and in the military, you call it the ranger-like, group, who have a higher standard in terms of the intensity that they take in life, versus let's say the army, which is prepared strong to a certain standard, but it's a different standard than the ranger, elite,
Right.
And you always have like the Navy SEALs and just the Navy, and you have always kind of these two categories. And I have heard entrepreneurs talk, some things that I'm still pondering about, things like, I prefer to have bad employees and great employees. The bad employees are easy to fire. The great employees are the ones that you want to keep. But the good employees are hard to fire because they don't do anything wrong that you have substance to fire them. It throws me off sometimes, statements like that, because I do understand that from the perspective of innovation, well, if you have a rush to get to be the first to innovate, you want to be in the Ranger squad, where time is of the essence and there is a level of urgency. But when we're talking on the topic of governance and we're talking about bringing people along and educating people and collaborating, that is no Ranger team. That is the team, the game of a team, so to say.
Right.
And
Absolutely.
So should every organization have two teams, like one that is focused on intensity and other one that is focused on consistency? Or how do we establish a set of standards that people will be able to flex the muscle accordingly?
Okay, so I think first I'll speak about what I know, okay? The national labs, okay? The U.S. national labs, they provide scientific and technical capabilities to deal with the challenges of this country. So these challenges change over time, right? They morph, they change. To deal with them, you really need a diverse workforce, people with different knowledge, different ideas, and so on. And everybody approaches something with their own sense of that urgency and importance and things like that. In general, not talking about edge cases, in general, in the national lab, I truly believe, when we come as like team science, kind of a team science approach or a team approach, okay, we augment one another, right? Okay, so collectively, we have the right sense of urgency or patience, whatnot. I gave you some examples, earlier. We're not really, the national labs are not for-profit organizations. We are here to deliver scientific discoveries, translate science to solution to benefit the economy, national security, energy, and environment. We have much higher level goals, right? Okay. Like if you look in, some people in the national lab, they can go actually outside, make a lot more money. Okay. I have people working on AI, they can make way more money. Why are they here? Because they are passionate about the mission. So there is different drivers, like that actually, and that's what gives them the sense of urgency, all of that, right? Okay. They want to contribute, etc. So somebody from the outside, they may see it differently. But what we see the passion and how they want to tackle problems and things like that. So it's really, the people we have are different. So now if you go into a startup, maybe your metrics are different, all right? You're looking at different bottom lines than we do, so maybe you look at people differently. I really prefer to look at people like we're doing here in the lab, where people can come together, they're diverse, they work together, they got a challenge that they're trying to address, and we together address it. That's the reason why some of us are here, because we feel there is missions, okay, we can contribute to these missions. It's not we're trying to maximize individually, right? And so it's a little different for us. Sometimes having these higher level drivers are really, really important. Like you're passionate about the environment, about people, okay, it's different, right? It's you have your drive, okay, is different than somebody trying to maximize bottom line, right? Yeah. And passion, and so that I think it's a little. It depends on the organization, but some startups, they're not patient at all. They want to deliver this, that. If they don't deliver, they may disappear, right? So take like when we talk about renewable energy battery companies. Many of the battery companies that started, say 2 years ago, they're not in existence anymore, right? So you have to deliver or you disappear, right?
Fair. That's a very fair.
It's a different
response.
attitude, right?
Yes. And I think more than casting a one solution for all companies, each company has a different set of drivers that they're moving towards.
Agree.
For each driver, a unique metric.
I agree. Like when I talked about Sheikh Moza bint Nasser in Qatar, she has her own metrics. She wanted to create a knowledge-based economy. They have, in Qatar, there's something called Vision 2030, and she was patient. She wanted to bring people along, right? Bringing people along is not easy. You need time, right? So it depends on the journey you're trying to consider.
Fair. You mentioned AI. What does the future look like for ORNL on the topic of AI?
So first of all, Ronaldo, I'm going to talk about all of our national labs. In terms like we talk about neural networks, machine learning, etc. We've been in that business for a long, long time. It's not, new to us, okay? I think, now we're, as a society, we're trying to harness the benefits of artificial intelligence and the models that we can generate. So I gave you an example, about geospatial intelligence. Mm-hmm. Give you another example where it's a great thing. You can digitize things. It takes a long time, and you may not be accurate, and if you need an urgent answer, AI can. So it increases the productivity. Like, for example, with the manufacturing demonstration facility, we can actually 3D print parts that actually are free of defects. How we do it, we use a lot of artificial intelligence. Now, again, we collect a lot of data, sensory data, we train the models on the data, and then we control the processes of rostering to make the part using that. And so we can create parts that qualify. Actually, we created brackets that are actually in a nuclear reactor here in Tennessee, right? You can create parts that you can put on planes to fly. So artificial intelligence actually can enable us, to do big things and new things. Like, for example, we have a facility. When I was the associate lab director for energy and environment, we started called Apple, the Advanced Phenotypical Lab. So mainly we have greenhouses here at the lab. We grow plants, right, and we put them on conveyor belts. They go into a head house where you have different imaging modalities. So we look at the plants, at the leaves, and so on. We actually relate the phenotype, the behavior, to the genotype of these plants. And one of the things we're trying to do is how do you adjust the genetics of plants such that they can tolerate drought, they can tolerate heat, and things like that. Well, this facility generates a huge amount of data. To be able to really be able to correlate things together, you need, models. Again, you have to make sure you got the data. You clean the data, look at the data ontologies, pedigree, and all of that, and so on. And then you run these models. So this is really a great set of things, right? Okay. So we here have done that. However, there is risk associated with artificial intelligence. For example, take the banking industry, right? Crooks could actually get at, say, your information or my information, your bank and my bank. So the banking industry now is creating, I'm going to say, counter artificial intelligence models where they know Ronaldo, when he accesses his bank, he accesses from this IP address. When he uses iPad, you use the right hand, you click this way, that way. So they're trying to build these models to detect, is it him, it's not him, etc. So I think, artificial intelligence will contribute to the advancement of humanity. I think it will contribute to automation, broadly speaking, right? And productivity. But then there is other risk associated with it, right? Security type risks, fraud type risks, and so on. That, some of these risks exist today. They're going to be amplified more over time, right, with the spread of AI. So we need to work together to figure out how we deal with them. I think it's going to be always, good people make some progress, bad people some progress, and you need to always back and forth and so on. But the promise of artificial intelligence is going to be huge. Why? Just take, drug discovery. We are going to be able to discover drugs a lot better. During COVID here at this lab, we looked at the, docking of certain drugs with the COVID virus. And you do screening studies. We're using supercomputers to do that, and so on. So artificial intelligence in science can offer you something equation-free. You don't need that. You could actually do a lot more of that discovery of drugs. Maybe you can do it in a lot shorter period of time, and you can help humanity, broadly speaking, right? Okay. So there is a lot of benefits, to being able to utilize data, utilize information like that to generate a new knowledge, right, that we can help us.
So in that sense, if I am understanding your perspective, it will help us be more productive, look for new solutions, be faster, or more optimized in what we do. So in some ways, it will speed up things. In terms of the processes that we do today, we're going to speed them up.
Right.
Just like before, without calculator and with calculator, we sped things up. As we look at how do we govern the information that goes into these AI models, and how do we govern the models themselves.
Sure.
Going into the topic of governance, when we're looking at things that are physical in nature, I think, it's quite easy for us to understand, physics-driven,
Right.
Rules,
Sure.
gravity, mass conservation, energy conservation, and okay, we do the math, we solve the problem. It's very physics-oriented. There are first principles to that. Do you believe that governance, which in many ways, and I'm maybe biasing an answer here, but it's not my intention, there is a huge human component to governance. Do you feel that there are first principles to governance?
Okay, so before I answer that, when you ask me about what do I see Oak Ridge in the future, I see Oak Ridge National Lab in terms of AI focus on two dimensions of AI, security and scaling. And to really make sure that, when you build these models, you build them based on large amount of data, but you're able to generate the models, in a timely fashion, right? And security of AI, making sure, security of the data, security of the models. I'm going to say maybe end-to-end security, right?
Yeah.
If including, the devices, the hardware, the software, including the data, etc. How do we actually do that? That to me is something we're trying to focus on, as a lab. I actually believe, when it comes to data, right? Okay, you need to use good principles in terms of, the data. You need to protect the data, right? So I think, one aspect when we look at and the whole aspect of AI, is, you need to look at the data, how the data is going to be polluted. Is somebody going to get to the data, tamper with the data, such that small adjustments or tweaks in the data will result in huge changes in your model and things like that. So the cybersecurity aspects are really important in the artificial intelligence space. So the intersection of cybersecurity and AI is what we call cognitive cyber, is really a big thing that you have to watch after. Right, so cybersecurity, protecting the data or protecting the models, is really, really important. And I think that's honestly, how people will get at anybody. Your adversaries will get at you by polluting the data, stealing the models, adding tweaks to your data. So you have to use, good data management practices, and then you have to have the right, firewalls, protections, and things of that nature. Now, in our case, clearly some data we have is private data, like let's say, anything to deal with personnel data. We have secure data. So you have different enclaves, how you protect the data, who has access to the data, what networks you operate, and so on. So there is other layers, we have to worry about. And I think maybe in the future, Ronaldo, maybe, one have to figure out how to store critical data, right, in a way that others have, certain access to it, not just an open access. Now, I'm not, to be honest and frank, I honestly believe open access is very important, right? But you have to balance security and access, right? And it's critical to do that. I don't think there is a physics-based model to say, this is what we do and so on. Like you said, you're dealing with the humans. Again, sociology and human behavior, is different and dominates different aspects. There's a lot of times insider threats. Right? What do you do with an insider threat or a person that is not trusted? And so there is no physics law that governs, but you have to put the right principles, the right processes in place to ensure, okay, that people who have the need to do something or have the right access, they do have the right access, and those who don't, they don't.
Fair. And we are coming to the end of our podcast here. I want to ask you about what are some meaningful metrics that let's say the C-suite in organizations, whether it's the vice presidents in labs or in universities, the deans and department chairs or the C-suite in the industry should consider to account for the culture that we want that they would want to create if they want to promote these sort of things like collaboration and innovation that comes about because of the collaboration. And I ask this question because it's easy to track some of the, let's say, the more technical metrics, the reliability, availability of systems. You do the math, you count, we see the trends, we define targets for that every month. At the end of the year, everybody seemed to be happy, at the executive level with those hardcore metrics. But there are some metrics that are of a human connection that I don't think that is as easy to define, but I was curious if you had some thoughts on that.
And honestly, for me, when I think about collaboration and the future in general, I think about workforce development. Okay, like we need to educate the next generation. We need to be inclusive in how we educate the next generation, right? Like for example, I went to the University of Texas at El Paso, okay? A great school. There is 15% of the students are from Mexico. They cross every day back and forth, right? You got a great school. You need to include them part of this innovation process. So for companies and labs and so on, having maybe more partnerships with universities, right, is a good thing. Really sponsoring, I'm going to say internships. You need to mold people in certain cultures so they learn how to innovate, and you need to jazz them up so they're excited and things like that. If we really, in this country, do more on workforce development, gender equity, across the board, white, black, blue, because we have here in Tennessee, in Tennessee right here, a lot of disadvantaged, areas that deserve every investment, right? It's not just certain, it's everybody, it's white, black, etc. We need to be inclusive. We need to really nurture that. The other thing is, a lot of times, when we think about like certain things like community colleges and we tend not to pay attention to community college, like artificial intelligence. Okay, why can't we actually get a lot of community colleges, to participate? Today, like when you look at Watson X, I can write the programs, but it's still, you have to do a lot of work. So there is ways to teach kids, across the board, to be part of the journey. I really believe companies in the United States can do a lot more internships. National labs can do a lot more internships. We should be really thinking about faculty, how to host the faculty and a few students with them so they're together, right? So the students feel safe. We need to think differently about how we work together, how we partner together in things like that. And in the national security space that I represent, it's really critical to trying to do that, but also work with the kids in the schools such that they actually, have clearances. We work with them to get clearances. We work with them such that they would be placed in a job, wherever, right? Mm-hmm. The more we do of that, the more we focus on our kid and workforce development, and with that collaborative spirit, the more we nurture great partnerships, but a great future.
I think you were foreseeing the future here. I was going to ask you, what advice do you have for us? And I think you have shared a remarkable set of advice here for all of us. My last question, what question do you think I should ask, whomever I go to interview next in my journey on the topic of AI and data governance?
I honestly believe, the big question is, what are we doing about AI trustworthiness, AI security? I think that is really a big thing. And how do we actually put that in layman's language such that people start to understand the risk and understand the potential? I think, to me, that's a critical question to ask.
Do you have an answer for that question?
I do. I think, in terms of AI trustworthiness and AI risk, as I said, like trying to think about end-to-end solution that include the hardware and the software is really important. I think in layman's language, AI has a lot of potentials, has certain risks, We need to, learn more. I think everybody should have at least, I'm going to say, modest knowledge of what AI is. A lot of people just hear the buzzword.
Yes.
They don't know what it is,
yes.
right? So it'll be good to actually have just something like that so people learn. And then, can we take these risks and put them into layman's language so people, like I mentioned, the banking question. That's a layman's language, like somebody accessing my account, your account, right? Okay, and they learn what key strokes you're doing, etc., right? And they can, right? So trying just to teach people broadly about some of the risks that consumers face would be a good thing. I'm not in that business, but I think that's, to me, is a critical thing to get comfort, to make people comfortable with the concept. And
That's
so
fair. That's fair, and I think that may be a call to action, that goes all the way to, K to 12, maybe education, and maybe embed these more critically in the curricula, in universities across the board.
Absolutely.
Very
Absolutely.
good. Mo, what a pleasure it has been visiting with you. Really,
Likewise,
thank you
Ronaldo.
for your time.
No, thank you. Appreciate it.
Absolutely.
Thank you,
Thank you.
sir. Thank you.
With that, folks, thank you for joining us.